Having 3 outlets in bathrooms without power can be frustrating. Firstly, check for hidden ground fault circuit interrupters, or GFCIs. Often, these are not in a typical outlet location, but may be tucked behind mirrors or towel racks. Carefully remove the faceplates of the affected outlets and inspect for any GFCI receptacles plugged into them. If you find one, press the reset button. Secondly, inspect the wiring connections at the affected outlets. Disconnect the outlets and carefully examine the wiring. Look for any loose connections or breaks in the wires. Ensure that all wires are securely fastened under the screws and that wire nuts, if used, are properly tightened. Loose connections can cause a loss of power. Thirdly, use a non-contact voltage tester to verify the absence of voltage at the outlets. Touch the tester to the terminals to see if it indicates voltage presence. If the tester doesn't light up, this confirms the lack of power. Fourthly, if you find a GFCI in the bathroom but the outlets still have no power, the GFCI itself may be faulty. Ground fault circuit interrupters can fail over time. Replacing the GFCI with a new one is a good troubleshooting step. Fifthly, re-inspect the circuit breaker panel. Even if you previously checked and didn't find a trip breaker or GFCI breaker, look again. Sometimes a breaker can trip slightly and not be immediately obvious. Reset any breakers that appear to be in the off-forward trip position. If a breaker trips repeatedly, there may be a short circuit or overload on that circuit. Contacting a qualified electrician is highly recommended if you've gone through these steps and still have no power to the outlets. Electrical work can be dangerous, and it's best to leave complex troubleshooting and repairs to a professional. When working with electrical circuits, always prioritize safety. Turn off the circuit breaker that supplies power to the affected outlets before doing any work. Use insulated tools and wear appropriate safety gear, such as safety glasses. If you are not comfortable working with electricity, call a qualified electrician. GFCI outlets are designed to protect against electrical shock. They monitor the flow of current and trip if there's a difference between the amount of current going out and coming back. This difference could indicate a ground fault, where current is leaking to ground, potentially through a person. GFCI outlets are typically required in areas where water is present, such as bathrooms, kitchens, and outdoor locations. The National Electrical Code, or NEC, specifies the requirements for GFCI protection. Common reasons for GFCI outlets tripping include moisture, faulty appliances, and ground faults in the wiring. If a GFCI outlet trips frequently, it may indicate a problem that needs to be addressed. It's important to understand the difference between GFCI outlets and standard outlets. Standard outlets do not provide ground fault protection. Replacing a standard outlet with a GFCI outlet can provide additional safety in areas where water is present. When replacing an outlet, make sure to use the correct voltage and amperage rating. The voltage rating of an outlet is typically 125 volts in residential applications. The amperage rating indicates the maximum amount of current the outlet can handle. Using an outlet with an incorrect rating can be dangerous. Wiring connections should be tight and secure. Loose connections can cause heat, which can lead to a fire. When making wiring connections, use wire connectors that are appropriate for the size and type of wire being used. Wire nuts are commonly used for making connections between solid wires. Crimp connectors are often used for making connections between stranded wires. Always follow the manufacturer's instructions when using wire connectors. When working with electrical wiring, it's important to identify the different wires. The black wire is typically the hot wire, which carries the current from the circuit breaker. The white wire is typically the neutral wire, which returns the current to the circuit breaker. The green wire is typically the ground wire, which provides a path for current to flow back to the circuit breaker in the event of a ground fault. Never connect the hot wire to the ground wire or neutral wire. This can cause a short circuit, which can trip the circuit breaker and potentially start a fire. When working with electrical wiring, always double-check your work to make sure that all connections are correct and secure. If you are unsure about anything, consult with a qualified electrician. Electrical safety is important. Taking the necessary precautions can help prevent accidents and injuries. Be aware of the potential hazards of electricity and take steps to protect yourself. Working with electricity can be dangerous, so it's important to take the necessary precautions. Turn off the circuit breaker before working on any electrical wiring. Use insulated tools and wear safety glasses. If you're not comfortable working with electricity, call a qualified electrician. Here's an elaboration on inspecting the wiring connections. Firstly, before you touch anything, turn off the corresponding circuit breaker. Confirm it's off using a non-contact voltage tester at the outlet itself. Secondly, carefully remove the outlet cover plate and then the screws holding the outlet in the electrical box. Gently pull the outlet out, being mindful of the wires. Thirdly, examine the wires connected to the outlet. Look for any signs of damage, such as frayed insulation, corrosion, or burn marks. Fourthly, check how the wires are connected. They might be connected via screws on the side of the outlet or pushed into backwire holes. Fifthly, if wires are connected via screws, ensure the screws are tightened securely. If wires are pushed into backwire holes, inspect the release mechanism. Sometimes these mechanisms fail, causing a loose connection. Sixthly, if you find loose connections, you might need to restrip the wires to ensure a fresh, clean connection. Use wire strippers to remove about ½ an inch of insulation. Seventhly, when reconnecting wires to screws, loop the wire clockwise around the screw before tightening. This helps pull the wire tighter as the screw is tightened. Eighthly, for back wire connections, ensure the wire is fully inserted and the release mechanism is functioning properly. Ninthly, if you find any damaged wires, it's best to replace them. You can purchase short lengths of wire at most hardware stores. Tenthly, after making your connections, carefully push the outlet back into the electrical box, ensuring the wires are neatly tucked away. Secure the outlet with the screws and replace the cover plate. Finally, turn the circuit breaker back on and test the outlet with a voltage tester or by plugging in a small appliance. An additional point is to ensure the electrical box itself is securely mounted. A loose electrical box can cause strain on the wiring connections. Regarding the non-contact voltage tester, hold the tester near the outlet following the manufacturer's instructions. The tester will indicate whether voltage is present. If it detects voltage when the breaker is supposed to be off, there may be another circuit feeding the outlet, or the breaker might be faulty. It is recommended to contact an electrician in this situation. When replacing a GFCI outlet, firstly, turn off the power at the breaker. Secondly, remove the old GFCI outlet. Thirdly, identify the wires. Typically, there will be a line side and a load side. The line side is the incoming power, and the load side is the power going to other outlets downstream. The GFCI outlet will be marked line and load. Fourthly, connect the wires to the new GFCI outlet, making sure to connect the line wires to the line terminals and the load wires to the load terminals. Fifthly, ground the outlet with the green or bare copper wire. Sixthly, carefully push the outlet back into the electrical box. Seventhly, secure the outlet with the screws and replace the cover plate. Eighthly, turn the breaker back on and test the GFCI outlet. Press the reset button and then the test button. The GFCI outlet should trip, indicating it is working properly. For the breaker panel inspection, look for any breakers that are tripped or off. A tripped breaker will typically be in the middle position. To reset a tripped breaker, firstly push it all the way to the off position. Secondly, then push it to the on position. If the breaker trips again immediately, there may be a short circuit. If a breaker trips repeatedly, it is important to identify the cause of the trip. Overloads are a common cause of tripped breakers. An overload occurs when too many appliances are plugged into the same circuit. To prevent overloads, avoid using too many high wattage appliances on the same circuit. Short circuits are another common cause of tripped breakers. A short circuit occurs when a hot wire comes into contact with a neutral wire or a ground wire. Short circuits can be dangerous and can cause fires. Ground faults can also cause breakers to trip. A ground fault occurs when current leaks to ground, potentially through a person. GFCI breakers are designed to protect against ground faults. They trip when they detect a small amount of current leaking to ground. Arc faults are another type of electrical fault that can cause breakers to trip. An arc fault occurs when there is an unintended arc of electricity between two conductors. Arc faults can be dangerous and can cause fires. Arc fault circuit interrupters, or GFCIs, are designed to protect against arc faults. They trip when they detect an arc fault. When checking the breaker panel, make sure that all of the breakers are properly labeled. This will make it easier to identify the circuits that are affected by a tripped breaker. If you are unsure about how to work with electrical wiring, it is always best to call a qualified electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself. Furthermore, if the outlets in the bathrooms are wired in a series, a problem with one outlet can affect the others. If the first outlet in the series has a loose connection, it can cause all of the outlets downstream to lose power. Finally, remember the NEC mandates GFCI protection for bathroom receptacles. If your home doesn't meet these standards, you may want to consider upgrading the wiring.